Well, I sent away to China for more of the same quality stuff to fix my light with. It'd be nice if I knew where to get a better quality light. I know a friend of mine was after me to get a better quality LED. I guess I'd have to go through I don't know, Mouser or somebody. So just to get going right away, I wanted to see what I could do with the eBay IC station. What's the other one? Where did I go? I'm not even sure where I went at the end. Anyway, here we go. Yeah, I'm not really sure which of the three that I was looking at that I actually purchased. They all had the same stuff basically, though. It was they even had the same sticker from the eBay to the one of the houses I was looking at. They had the same, pretty much the same sticker on the LED power supplies. And I didn't really want to get the Chinese LED. I thought there's supposed to be Chinese LEDs in here too. Oh well. These are supposed to come with LEDs as well, which I don't think I really need. It's a little disappointing that they're not here though. Alright, so I've got the new power pack installed. Just loosely, I want to make sure this is going to work before I bolt everything together. So one of these is installed and soldered onto the chip, and I made sure it was going to work. Boom! 1 second delay, just like I had with the other ones, before it blew up actually. So it's working just like it did originally. It's kind of interesting the way these LEDs glow as the power drips off. They just got like 2 or 3 that are shining still. So anyway, I just got to neaten this up, put it back together. It looks nice and bright. I'm going to put the power supply, I'm actually going to glue it to the side of the housing with epoxy. Because they put it in, they glued it in with RTV, which isn't the greatest in thermal transfer, to say the least. So I'm going to do a little better with epoxy, I believe. Stuck to the side, probably right there, so I think most of my wire lengths. And it'll be able to dissipate heat to the housing and to the rest, the bigger part of the housing. Okay, I've got everything assembled again. I tested it raw and it lit up nice. Put it all back together. What I probably should have done before I put it all back together was to look at it on the kilowatt. And I got a real interesting result. This is the 50-watt unit, and I got glare, you probably can't see it too well. Let's see what happens when I turn on. Same 1 second delay the other ones had. But look, I'm up to 71. Is that right? Make sure I'm in the right mode here. It's coming down slowly. Yeah, and the VA versus the watts are pretty close. 6.9 versus 70 rather. 69 versus 70, but this is a 50-watt unit. Nice and bright, much brighter than my little other 50-watter. I got another 50-watter that's only 21 watts in reality. It's not very bright. I'm thinking of putting the other power pack in that one. I bought 2 power LED power supplies. At any rate, going to the, what I should have done is put this on the kilowatt before I got any more involved. And toggling between VA and wattage, they're both pretty close, about 67. When I first plugged it in, it was doing 71, but it's kind of come down slowly as it gets hot. It's getting pretty hot, so I don't think this is going to last in the long run. I don't really know what's going on wrong here, if the device is putting out too much current current limiting isn't working correctly or what. So here's two of these spotlights, and even though they're slightly different vendors that I purchased them from, well, this is the LED headlight, floodlight. You know, they got the same sticker on the back even. But it seems like whoever you buy these from, they have the same case, but they don't necessarily have the same guts. This one says Tech Box. This is the one I did a video on a year or two ago. I never put this thing into use because it only draws 21 watts. You know, or it should be drawing closer to 50. It's 50 watt rated. And of course this one's doing 71 now, which is probably going to burn up. So, just to be sure that the one is brighter than the other, I had an expert come in from Ohio, an LED expert from Ohio, and I'm going to get his opinion on these two lights. So we took it apart again. Only 2 screws in this reflector out of the 4, and then of course the 4 corners on the... Anyway, put some paper underneath the contacts so we can get alligator clips on them. If you plug that in, sir. Boom! Wow, 151 volts. 158? What? What?
That's got to be your meter.
No, my meter's pretty... never screwed up before. Wow. This thing is really screwed up.
There's no way there's...
Now it's down to 128, 123.
That LED would be popped if that was that high.
Well, let's use a second meter, then we'll double check this. I don't think this meter's wrong, because this meter's never wrong. It's a Vellerman quality. Okay, so I've clipped a very high quality meter in place of the other meter, just to be sure. Go ahead and plug it in if you would. That our meter's not lying to us. There's a little beat off voltage going there. Whoa, that blinds our eye. It's over range. 200. Yeah, no, this is more reasonable. 57, 50, 49. That's more, but it's still too high.
I still think
these aren't supposed to be able to put out more than 40 volts.
I still think the AC ripple's throwing this thing off.
Well, let's put a cap on and see. You're about to lose your eyeballs. Boom! And we are over range. What the hell? Yeah, it didn't do it. Wow, it's 175 volts? Why is this meter getting tricked out? And now the drain down is in the 20s.
This thing's...
That meter's always been good. Huh. Boom. It's over range. Shit. No way. That's not put out no kilovolt. Weird. There must be so much noise in that line. It's just unreal, huh?
Yeah, I guess.
So we put a 0.22 ohm resistor, because that's what I had handy, in series with the load. Hung the caps across just for the heck of it too. Kind of hard to see out of the light. And we used 2 different meters again, because he's getting a lot of bounce stuff going on. We're getting, I'd say roughly 1.5, which isn't going to work out right because it's a 0.22. What'd you get on the other meter? About the same?
It went off the scale.
The other meter went off the scale? Wow.
I think it's a high frequency ripple, or the 120 hertz ripple.
Yeah, probably high frequency.
Throwing the readings off.
Would be my guess.
You have to scope it, really, is the only way.
So we were thinking that there's too much noise in RF, or whatever else coming out of this chip, in inverter, LED power supply, I should say. So we hooked up an analog meter, and we are getting way different readings. Now we're getting 0.5 volts. And we're still getting, this reading, when we do the math, still comes out a little bit odd. You came up with how much current?
What was it, 2 point... let me figure that up real quick.
But we figured out it's not valid because he did the math. The current is still too high, which I know this is running too hot and too high. But it's not believable because when we did the math and you multiplied the current times the voltage that we measured, and it comes out way higher than what we're measuring off the kilowatt for wattage.
Yeah, 107 watts at 2.2 amps. It's just.
And the kilowatt's showing a 71 falling down to 6.7, I mean to 67 rather. So it's still a mystery. We may have to break out the old oscilloscope to figure this out.
Well, let's put the analog meter across and get a.
We're measuring voltage across the chip with an analog meter. Now we're only getting 39 volts, which is still high, but I know we're high because we're out of spec here on wattage. But that's probably a more reasonable reading. It's probably closer to the truth. Just to see if the other unit, maybe I got a bad unit, I'm going to try the other unit because I bought a pair of these for that fixture that's only doing 21 watts. So it's just going to got the LED power supply in this brand new unit and throw one of these in, throw this one in particular in. But what we've done here is we've disconnected one wire from the unit internal of this, and we've just kind of stuck this unit in loosely just to see if we get the same results as we got with the other one. And right now we're set up to measure current across that resistor. And we still got the caps in to smooth out the AC a little bit, well, the DC a little bit. And by the way, that's two, they're 22,000
2200
UF caps, and they're split in half, so only 11,000 or
1100.
I thought they had another zero on them. Anyway, they're 50 volt caps, so together they can take whatever we throw at them, hopefully. All right, let's go for a plug-in. See what happens. Analog meter.
Get that set.
Yep.
And cord. If I blow up on me. Pow.
Boom! Oh, that hurts my eyes. That's just as bright as the other one.
Yeah.
Well, the current's not as high though. We were measuring 0.5 before. Let me get this down. We're in the same range. Apples and oranges. We're doing current here, right?
Yes.
That's gonna be over.
It's the same.
Yeah, it's a little higher. We only did 0.5 before. Now we're doing more.
Hair more.
Yeah.
Yeah.
5.5 more. Is that 5.5 or 6? That would be. All right, so I've got a load I use when I'm testing power amps. This has got some big power resistors soaking in oil to extend their wattage rating even further. Anyway, long and short, the way I've got it paired together, I'm getting about 17 ohm load, resistive load that I'm putting across this LED power supply. I just want to characterize the voltage and current and see if it's within what it should be doing. It should give me a 1.5 amp constant current regardless of my load. So the LED I calculated would be about a 22 ohm load. Rough numbers, it's very inexact. But roughly a 22 ohm load, if it was a 50 watt unit and was drawing 1.5 amps, it should have. Anyway, I'm going to see what I get this ways. And I'm getting, I'm in between ranges, that's not good. 50 watt, so I could probably use the doubler deal. Yeah, so I'm right on the top. So that's the 25 range. So I'm getting 25 volts basically on a. So that's wrong. This unit is wrong. On the scope, we can see there is a predominant 60 hertz. I don't have those two capacitors on there anymore, but there's a predominant 60 hertz to the waveform that would have made it hard for us to measure. And I'm going to blow up one of those peaks just to see what that RF looks like that's inside of that peak. It's at 20 microseconds, about as good as I can get it. And back to the overall signal, this 60 hertz waveform, I presume, is about 7 volts peak to peak. I'm at the 1 millisecond setting. So 22 volts on 17 ohms. We'll calculate it out and be right. So to test this unit, and of course this is, what I really need to do is test the one that's in here, but this is the spare unit. We got pretty much the same results though. Actually this one was even a little hotter. So checking this unit out at any rate, we got 25 volts and we've got a 17 ohm load on it, and we calculated it out to 1.47 amps. So it's actually doing its job correctly. It's supposed to be a 1.5 amp constant current source supply. So it's doing its job. The only thing I can think of is my LED is way out of spec. And I'm probably just going to put this thing all back together just pretty like it was and just let it burn. Winter's coming up. If it survives, and maybe it'll be able to take it in the winter. It'll probably die next summer, if not sooner. So that's what I'm going to do. I'm just going to take this thing all apart, put it back like it was, and let it burn. And I think I'm going to try the other unit since I know it's doing its job. I'm going to let this one do the same thing. I'm going to put a different unit in here and get it brighter, because this is 21 watts, just